Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will discuss a topic of S2 where we perform hypothesis test on a sample mean. But before we start off with the topic, there is something that we need to recall. If I have a sample data, then I can use the mean of the sample data as an unbiased estimate of the population mean. Similarly, if I have sample data and I use it to calculate the variance of the sample, that itself will not be equal to the unbiased estimate of the population variance. So I will use the sample variance and multiply it by n upon n minus 1, where n is again the sample size. I will get myself the unbiased estimate of the population variance. In simple words, the unbiased estimate of population variance, if population variance is not known, can be estimated by sample variance by using the formula n upon n minus 1 times sample variance. Other thing that you must be able to identify regarding sample mean is that if X follows a normal distribution with mean mu and variance sigma square, then X bar must also follow a normal distribution with mean mu and variance sigma square divided by n, where n again is the size of the sample. I should know the mean population and I should know the population variance. If I don't know them, I can use their estimates only if sample size is bigger than 30. And I also must know that applying central limit theorem, there is no condition of the population to be following normal distribution. So if n is bigger than 30, then whatever is the original population distribution, or if the population distribution is not known to me, even then the sample mean must follow the normal distribution. Whatever is the X distribution, or if it is like entirely unknown distribution, I can say that sample mean follows a normal distribution with mean mu and sigma square over n, by applying central limit theorem only for those situations where I'm taking the sample size bigger than 30. Now let's move on towards the steps of the hypothesis testing. What are the steps that I need to do to perform a hypothesis test on sample mean? So I will read the question, I will identify the null hypothesis as the mean value, which is the pre-established value of the mean. And then I will see what I'm looking for. Am I looking for an increase in the mean? So it's going to be mu is greater than mu naught. It will be one tail upper tail test, where my critical region should lie at the upper tail of the distribution. If alternately I'm looking for a decrease in mean, then my alternate hypothesis would be mu is less than mu naught. It will be a one tail lower tail test, and the critical region must lie at the lower tail of the distribution. If I am looking for a change in mean, I'm not very sure whether it has increased or decreased, and I want to find out the alternate hypothesis of a change in the mean value, then that means that it's going to be a two-tail test. And my significance level is going to be equally divided at the two tails. So alpha by 2% at the lower tail and alpha by 2% at the upper tail. My way forward is that always, with the assumption of null hypothesis to be true, I will write down the distribution of the test statistic. So if n is greater than 30, then X bar always follows normal distribution. But if n is less than 30, X bar would only follow normal distribution if X is originally normal. I will write down the distribution of X bar. I will use normal distribution table to identify the critical region, the region of the acceptance of H1, and obviously the region outside that would be the acceptance of H0. After finding out the critical region, I will be given a certain test value, and I'll perform calculations on the test value to convert it into a Z value and check where does it lie. Does it lie in the critical region or non-critical region? So once I've identified where my test value lies, then I will draw a conclusion that H0 is accepted or H1 is accepted. And after drawing a conclusion, I just need to write down a supporting statement with context of the question. Let's have a look at some example questions. Now this is a question from June 23, variant 61. It says in the past, the annual amount of wheat produced per farm by a large number of similar sized farms in a certain region had mean value of 24.0 tons and standard deviation of 5.2 tons. Last summer, a new fertilizer was used by all the farms, and it was expected that the mean amount of wheat produced per farm would be greater than 24 tons. In order to test whether this was true, a scientist records the amount of wheat produced by a random sample of 50 farms last summer. He found out the value of the sample mean was 25.8 tons. So this is my test value. With stating the necessary assumption, I have to carry out the test at the 1% significance level. So since we are looking for the increase in the mean value, my H0 null hypothesis would be mean is equal to 24.0 and H1 would be mean is greater than 24.0. With the null hypothesis to be true, I write down the distribution of sample mean, which will be 24 and 5.2 square over 50. And I have used a central limit theorem over here because I did not know the original distribution of the population. Since the sample size is bigger than 30, so I can say that X bar must be following a normal distribution. So what assumption are we making? Since the fertilizer has been changed, there might be a change in standard deviation as well, but we are assuming that the standard deviation remains unchanged or the variance remains unchanged. I have to perform the test at the 1% significance level. Since it is a one tail upper tail test, so my upper tail must contain 1% probability. So I will find out phi inverse of 0.99 looking at the normal probability table, and that comes out to be 2.326. So I know that if a value lies above the 2.326 value, then H1 will be accepted, and if it is below 2.326, it will be the rejection of H1 and acceptance of H0. The sample mean was found out to be 25.8 tons. So I will do calculations of converting that 25.8 tons into the normalized variable. So I apply the formula Z is equal to X bar minus mu over sigma upon under root n. X bar is 25.8, mu is taken from the distribution 24.0 divided by square root of the variance. And this comes out to be 2.447. 2.447 is greater than 2.326. It lies in the critical region, so that means that H0 is going to be rejected and H1 will be accepted. This tells us that the test value lies in the critical region, H0 is rejected, and the mean value of wheat has increased. Looking at another question, it says, this question is from November 2362. It says the height h in meters of mature trees of a certain variety is normally distributed with standard deviation of 0.67. In order to test whether the population mean of h is greater than 4.23, the heights of a random sample of 200 trees are measured. Write down the suitable null and alternate hypothesis for the test. So your H0 is going to be mean is equal to 4.23, and since you're looking for an increase, the H1 is going to be mu is greater than 4.23. Once we have written down the null and alternate hypothesis, we also have to perform a hypothesis test at the 5% significance level. With the assumption of null hypothesis to be true, I write down the distribution of sample mean. The population standard deviation was known as 0.67, so the H bar's variance would be 0.67 squared divided by 200, the size of the sample. Since it says the result of the test is to reject the null hypothesis, so we know that our test value lies in the critical region, and if the test value lies in the critical region for 5% significance level, that the critical region is going to be greater than 1.645. So that means Z has to be greater than 1.645. To convert H bar into Z, I will apply the formula, which is H bar minus mu over sigma upon under root n, and I know that this has to be greater than 1.645, and that tells me that H bar has to be greater than 4.31 for alternate hypothesis to be accepted. In another part of the question says, Ajit said, in B, we had to assume H bar is normally distributed. So it was necessary to use the central limit theorem. Explain whether you agree with Ajit or not. No, we do not need to apply the central limit theorem because it is already told that the population is following a normal distribution. So if population is normally distributed, so that means that the sample mean must always follow normal distribution, and we don't need to apply the central limit theorem onto that. So guys, let's have a look at another question, that is March 2462. The heights in centimeters of adult females in Lithuania have mean mu and standard deviation sigma. It is known that in 2004 the values of mu and sigma were 163.21 and 6.95. The government claims that the value of mu this year is greater than it was in 2004. In order to test this claim, a researcher plans to carry out a hypothesis test at 1% significance level. He records the heights of a random sample of 300 adult females this year and finds the value of the sample mean. First of all, it says state the probability of type 1 error. So you have to recall that type 1 error is the probability of accepting H1 with H0 being true, and probability of type 2 error is accepting H0 with H1 being true. Here we have to calculate the probability of type 1 error. If you relate this with the examples of binomial and Poisson hypothesis testing, our significance level was not equal to the probability of type 1 error, because if you have a 5% significance level and you have to find the probability of type 1 error, then you have to look for those integer values. That is not the case over here. Here, your significance level will directly be the probability of type 1 error. That's why the question says as well, state the probability of type 1 error, because it is a continuous variable, and since this is a continuous variable, so the entire critical region is the acceptance of H1 for H0 to be true. So I can directly state it will always be the case with sample mean that the significance level would be the probability of type 1 error. So I can state that, and that's going to be 0.01. We are looking for an increase for the mean. So obviously my null hypothesis is 163.21 to be the mean value of the heights of the females, and H1 would be mu is greater than 163.21. You should assume that the value of sigma after 2004 remains at 6.95. So we can assume that later on the value of standard deviation did not change. Now, given that the mu this error is actually 164.91, calculate the probability of type 2 error. So we have to calculate the probability of type 2 error, that is the acceptance of H node, the non-critical region, but for that you will be given a new value of mean, which is being provided to you, because obviously since your null hypothesis is wrong, so your mean must be greater than 163.21, so they must provide you with a value of mean to be able to calculate the probability of type 2 error, which is provided over here, which is 164.91. So you have to find out the probability of non-critical region with the new value of mean being provided to you, which is 164.91. But you do calculations on the previous distribution to find out the critical region. So if you will find out for 1%, your critical region is at 164.14. So 164.14 greater is your critical region, and less than 164.14 is your non-critical region, the acceptance of H naught. You rewrite your probability with the new value of mean and the same value of standard deviation, because it has been told that we have to assume that the standard deviation has not changed. Now, to calculate the probability of type 2 error, I need to calculate the probability of non-critical region, which is less than 164.14. So I will find out the probability of less than 164.14 with the new value of mean, which is 164.91. So I convert this into Z variable, and that comes out to be less than negative 1.919, and less than negative 1.919 is 1 minus phi of 1.919. I go to the normal table and read the probability of 1.919. That comes out to be 0.9724. So 1 minus 0.9724 gives me the probability of type 2 error. Have a look at another example. This is June 24, variant 62. The masses of cereal boxes filled by a certain machine have mean 510 grams. An adjustment is made to the machine, and an inspector wishes to test whether the mean mass of the cereal boxes filled by the machine has decreased. After the adjustment is made, he chooses a random sample of 120 cereal boxes. The mean mass of these boxes is found to be 508 grams. Assume that the standard deviation of the masses is 10 grams. Test at 2.5% significance level whether the mean mass of the cereal boxes filled by the machine has decreased. So this is like, unlike previous example, this is a one tail lower tail test because we are looking for a decrease in the value of mean. My H0 would be mu is equal to 510 and my H1 is going to be mu is less than 510. Now X bar follows a normal distribution with null hypothesis being true, mean is taken as 510 and variance is going to be 10 squared divided by 120. We have to apply a central limit theorem over here because we don't know the distribution of the population. But since the sample size is greater than 30, applying central limit theorem, X bar must follow a normal distribution. So I have written down the distribution of sample mean and I have to perform the test at the 2.5% significance level. So I will see the value of Z for the critical region, which is going to be negative of phi inverse of 0.975. I go to the Z table and from the standard values I can read Z is negative 1.960. So I know that if my test value lies below negative 1.960, I'll accept H1, otherwise I'm going to accept H0. So I have a test value given to me and it is found to be 508 grams. I convert 508 into Z value and that comes out to be negative 2.19. Negative 2.19 is smaller than negative 1.960, so it lies in the critical region. H0 is rejected, H1 is accepted, that is the mean mass of the cereal has decreased. Another part of this question says, later the inspector carries out a similar test at 2.5% significance level using the same hypothesis and another 120 randomly chosen cereal boxes. Given that the mean is now actually 506 grams, so that means null hypothesis is false. We have to calculate the probability of type 2 error. So with alternate hypothesis being true, we have to calculate the probability of non-critical region. So we have to calculate the probability of this particular region, the H0 acceptance. But I would need to know this critical value. So I will use the Z value to find out the corresponding critical value by using this distribution. So when I perform calculation on that, that comes out to be 508.2. With new mean being provided, the probability of type 2 error would be a probability of greater than 508.2. I will calculate probability of X bar to be greater than 508.2 and I will convert into a Z variable and then I look at the Z table and I'll get my answer of the probability calculations. Now, the questions that we have done up till now, we were provided with the population variances. Something different about this question is that I have a sample data, but I don't have the population variance and population mean. So with a sample of 50, the sigma x comes out to be 23.0 and the sigma x squared comes out to be 13.02, which means I have to use the unbiased estimate of population mean and population variance. I will calculate the mean of the sample and I can estimate that as the unbiased estimate of the mean of population. I can also calculate the variance of the sample, which is sigma x squared over n minus x bar square, but I need to multiply it by n upon n minus 1 to turn it into an unbiased estimate of the population variance. Once I've done that, I have to perform a hypothesis test of mu is equal to 0.5 against mu is less than 0.5. So my null hypothesis is mu is equal to 0.5 and alternate is mu is less than 0.5. With null hypothesis to be true, I will write down the population of sample mean. Since sample size is bigger than 50, despite not knowing the population distribution, I can claim that sample mean must follow normal distribution applying central limit theorem. So the mean is going to be 0.5 and variance is going to be 0.04980 divided by n, which is 50 in this case. Now, after I have written down the distribution, I know that I have to perform a one tail lower tail test with 5% significance level. So I'll find out the critical value of Z and that comes out to be negative 1.645 by looking at the normal table. And then when I perform calculations on the sample mean that I got over here and I put it in this Z formula, Z is equal to X bar minus mu over sigma over under root n, I get Z as negative 1.267. So negative 1.267 is bigger than negative 1.645. That means it lies outside the critical region. H1 is rejected and H0 is accepted. That is, it is not below the permitted level. In another part of the same question, it says later a similar test is carried out at 5% significance level using another sample of size 50 and same hypothesis as before. You should assume that the standard deviation is unchanged given that in fact the value of mean is 0.4. That means that H0 is not true. The mean now is 0.4. I have to find out the probability of type 2 error, that is acceptance of H0. That means I have to find out the probability of non-critical region. And for that, I must need the critical value. So I will use the Z value to find out the corresponding critical value as Z equals sigma Z over under root n plus mu. And once I get myself the critical value, I write the distribution with new value of mean provided to me for type 2 error, and I will calculate the probability of x bar to be greater than 0.4481. So I will calculate probability of greater than 0.4481, convert it back into Z by using the formula x bar minus mu over sigma over under root n. And then I will just do simple calculations using the normal probability distribution table. I need probability of Z is greater than 1.524. That will be 1 minus phi of 1.524. This value is read from the table, and this gives me the probability of type 2 error. Guys, I hope it was helpful towards understanding how to perform the hypothesis test on sample mean and how to calculate the probabilities of type 1 and type 2 error. If you found this video helpful, I would really appreciate if you would subscribe to my channel and also give a thumbs up.